All right, this is HC1. The first two problems are algebraic equations, so we're solving for the variable. I noticed that both of them have variables on both sides. So if you have variables on both sides of the equation, then you might end up with one of those strange identity or empty set problems. So remember what an identity problem looks like is maybe if you had 7g plus 8 equals 7g plus 8. Of course it does, that's its identity. So whatever g you put in there, it'll work because you're doing the exact same math. You're multiplying it by 7 and adding 8. You're multiplying by 7, adding 8. So you would have infinitely many answers to this. So we call that an identity problem. If you had 7g plus 8 equals 7g plus 10, now you have what is called an empty set because 7 times g will be the same. But then you get 8 equals 10, and of course 8 cannot equal 10. So there is no number that will make that a true statement. So that's an empty set problem. All right. So let's now go solve that problem. First one, I would do distributive property. That would get me 8g minus 36 equals 25g minus 14. I want to get my variables alone. So I'm going to subtract 8g from this side and from this side to keep it even. That gets me 17g minus 14 equals negative 36. Now I'm ready to solve this two-step equation. So they did this, then this. So I need to undo that. The opposite of that is add 14 to both sides. These have different signs, so I actually need to subtract sign of the larger. And I am down to negative 22 equals 17g. I divide by 17, and my answer is negative 1 with 5 remainders, so negative 5 and 17, and there's your answer. All right, let's try the second one. Number 2. Number 2, I would need to be careful right there at that negative, so I'm going to have to do leave change opposite and put a 1. I don't like the way that happened, so I'm going to have to erase that and start over. Leave change opposite. Anyway, that becomes a negative 1 right there. Leave change opposite right there. Leave change opposite right there to get rid of all my negative minuses. Now I'm going to distribute, which leaves me a 7 plus a negative 12 plus a positive 5y equals 28 plus a negative 12y. I'm going to combine my like terms right here. Those two become a negative 5 together. And I'm going to get rid of this 5y by subtracting 5y on both sides. So now I'm at negative 17y and a 28 equals negative 5. Now I'm ready to solve that two-step equation. Of course, I should probably have a plus and negative 17y now. They did this, then this, so I need to get rid of that. I subtract 28. I subtract 28, leave change opposite, that gets me negative 33 equals negative 17y. Divide by negative 17, and I get 1 and 16/17. Okay, so y equals 1 and 16/17. Number 3, we're trying to find the volume of this sphere. Remember our formula for volume of sphere is 4/3 radius cubed pi. We're going to use 3.14 for pi. That 11 that they gave us is a radius, so we want 11/3 to the third power. So this is our work. It says round to the nearest tenth. We do not want to round it now because we'll be rounding off a whole lot of pi's. We want to wait till the very end and then round it. So let me type that in. That is 11 to the third power times 3.14 times 4/3. I get 5572.45, so that rounds up to 5,572.5 units cubed because we're filling it up with units cubed. All right. Next one it wants is the surface area. Remember what we talked about with surface area is it takes exactly 4 circles to cover a sphere, so surface area of a sphere equals 4 radius squared pi's. In other words, 4 of the circle areas is what it takes. So I find that by taking 11 squared times pi and then taking it times 4, and I get 1519.76, and those will be units squared because we're talking about squares to cover it. It does not say to round this one, so I'll leave it full. Number 5 through 12. All right, number 5 through 12. I'm going to do these. I like to set up 2 so we can simplify them in sections. And this top one would be 2 to the negative third, which I'm going to go ahead and put in on the bottom as 2 to the positive third. Remember, negative exponents move from numerator to denominator, or denominator to numerator. Then I have g to the negative ninth, which is a g to the positive ninth on the bottom. Then I have an h to the negative 12th, which is an h to the 12th on the bottom. And then I have an m to the positive 15th, which stays on the top as an m to the positive 15th. Go to the bottom. On the bottom, I have 2 to the 4th. It stays on the bottom because it's a positive exponent. I have a, should have shown you that, a 2 to the, or a g to the negative 32nd, which moves to the top as a g to the positive 32nd. I have a h to the 24th, which stays on the bottom as an h to the 24th. And I have an m to the negative 40th, which moves to the top as an m to the 40th. Now I'm going to combine all of those. So on the bottom, I have 2 to the 7th. That's 2 to the 3rd times 2 to the 4th is 2 to the 7th. Here I have g's on top and bottom. They cancel each other out. These 9 on the bottom are going to knock out 9 on the top, and so you're left with 23, so g to the 23rd on the top, as they cancel each other out. On the bottom, I have h to the 36th. Multiply these two together, h to the 12th times h to the 24th. We add those exponents. And then on the same thing on the top, I have m to the 55th. So what I have here, if I'm putting this in my answer, I have 2 to the 0 power because I have no 2's up top, so that'd be a 2 to the 0. I have a g to the 23rd. I have an m to the 55. I don't have any h's, so that's a 0 power again. I have 2 to the 7th power on the bottom. I have no g's, that's a 0 power. I have 36 h's, and I have 0 m's, and so that's all of those put together. Number 13, if the volume of a figure is 12 units cubed, what would the volume be after a scale factor of 4 is applied? Well, the mistake that most people do make is they just take 12 times 4, and they say, well, 48. 12 times 4 is 48, so the new volume is 48. But remember, if you had something like this rectangular prism, and you took it times a scale factor of 4, that means that each is getting 4 times as big. So this side is getting 4 times as big, this side is getting 4 times as big, and the length is going to be 4 times as long. Sorry, had a call there. So now that means I need to take it times 4 not just once, not just twice, but 3 times, or take 12 times 4 to the 3rd power. And when I take 12 times 4 to the 3rd power, I should get, I think, 768. Yep, 768 units cubed. Sorry, I'm not sure where I was, but it was 768 units cubed was the answer to that one. All right, number 14 is a review on standard notation. Remember, scientific notation is telling you to multiply a number between 1 and 9.9 repeating, in other words, a one-digit number, times a power of 10, which just moves the decimal. So this is telling you to move the decimal 3 times, and since it's a negative 3rd power, it's saying move the decimal 3 places to the left. So if I have that 2.75, I move it 3 places left. There's 1, 2, 3 places left. Your answer is 0.00275, or 275, that's tens, hundreds, thousands, 10,000s, 100,000s, 275 100,000ths. All right, leads us to the last one, which is slope of this line. Remember how to find slope again. I'm going to maybe increase the size of that so you can see it a little bit better. Slope of that line. If we go to the slope of that line, you can do it several different ways. You can count the rise and the run. So you might say from this point to the next point, it went up 1, 2, 3, 4. Up as a positive motion. And it went right 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So it went up 4, right 6. We would simplify that to 2/3. So the slope of this line is 2/3. By the way, if you counted it the other way, it would be fine. You would be counting, it would go down 4. There would be your negative 4. And then left 6. And a negative divided by a negative is still back to a positive. So either way, your slope is 2/3. Again, you can do that by doing difference of y. So doing 13 minus 9 over difference of x in that same order. 11 minus 5, 13 minus 9 is 4, 11 minus 5 is 6, and of course simplify it to 2/3. Okay, so now we know it's y equals 2/3 x. You can tell by looking at this thing it's not going to hit the y-axis, right? So, or you're not going to hit the y-axis at 0, so it's not proportional, which means it has a boyfriend. So let's go ahead and start writing it. It's y equals 2/3 x, and we don't know the rest of that stuff, but I do know this. I know either one of these points, so I know 5, 9, so I know that when I put in an input of 5, and then I add some unknown number, that I get an output of 9. Does that make sense? 2/3 times the input of x, 5, plus the boyfriend that we don't know yet gets me to 9. So if I did this and work this out, this would be 10/3, which is 3 1/3, plus b equals 9. So if I am going to solve for b, of course, I need to subtract 3 1/3 from both sides, which gets me 5 2/3. Now it asks for it as an improper fraction, so let me change that back. That would be to give me 17/3. So that's where it's going to hit the y-axis at 17/3, and we can do that exact same thing. Now that we know that, how do I find the x-intercept? Well, now that I know the equation is this, that equation, I can simply put in the x-intercept by getting y to be 0. So let me change and make y 0. So I would subtract 17/3 and divide by 2/3. So I'd be at subtracting 17/3, which gives me negative 17/3, equals 2/3 x. Of course, I can do divide by 2/3, or I can multiply by 3/2. Those cancel out, and so you end up with negative 17/2, and it wanted as an improper fraction, so negative 17/2 is your last answer. We might not have gone over yet, according to when you get this on this strange year of remote teaching and remote learning. Where will 2, -7 be located after being reflected across the x-axis? Well, let's go to 2, -7. I'm going to plot that. 2, -7 would be right down here. Oops, not if I can't plot like that. 2, -7 would be right down here. And we're saying we're flipping it or reflecting it, which is a flip across an axis, which gives you a mirror image. We're going to go across the x-axis. So here's the x-axis. If I think about where it is in relation to that x-axis, it's 7 below that x-axis. So where would it be if I flipped it across there and had a mirror image? Instead of being 7 below, it would be 7 above on the same area, but it's going to be directly above. So you can look over here on the right. I posted some notes on this. You have line reflections. If you're going across the x-axis, here's the one we're looking at. You basically take whatever the x is and you go to the opposite of y. So x opposite y is what you're thinking. So if I look back at this point of 2, -7, and I go x stays the same, opposite of -7 is +7, and that's exactly where that point is at 2, +7. The next question just says, oh, I guess it asks for both of those. So that's where it is on the x and the y. So your answer for number 15 would be 2, and your answer for number 16 would be 7. So the next one says, where will -4, +11, so let me go ahead and plot that real quickly. I'll plot that with a different color maybe. So -4, +11 would be way up here. And it says, where will it be after being translated right 7 and down 5? Well, here's your translation rules down here. Translations are saying we're going to take that and leave it oriented the exact same way, but we're just going to slide it in the movement that they talked about. So if I slid that thing right 7, it would be going 1, 2, 3, 4, 5, 6, 7. Man, I'm not very good at counting on here. And down 5. So down 1, 2, 3, 4, 5 right there. So that is the new position of that. Another way to do that is to just take the point where it's at, -4, 11, and do it with the numbers. So if it says translate it right 7, that's adding 7 to the x. So now it's at +3. And it says down 5, that's subtracting 5, so now it's at 3, 6. And if you look at where this is, it's at positive 3, positive 6. There's your answer for number 17. There's your answer for number 18. Okay.